Good morning, dear students. I am Dr. Srinivas Bathani, Professor of Chemistry in St. Peter's Engineering College. Today, we will discuss the atomic and molecular orbitals. What is the topic today? Atomic and molecular orbitals. Atomic and molecular orbitals. This is our topic. In the last video, what we have discussed, what are the topics? What I explained, just introduction, the basic science, basic chemistry, atom, molecule, principal quantum number, azimuthal quantum number, sigma bond and pi bonds I explained. The electrons are present in where? In orbitals. The orbital, what are the orbitals present? S, P, D, F. We have discussed in the last class. I explained the introduction. S, P, D and F. S orbital, spherical shape containing the 2 electrons. P, 3 orbitals, it's a dumbbell shape. 6 electrons. And D, double dumbbell shape containing 1, 2, 3, 4, 5 orbitals. Totally 10 electrons carrying. So this is already we discussed in the last class. So S orbital, P orbital and D orbital. Orbital carrying the what? Electrons. So today, so what is our topic? Atomic and molecular orbitals. This is the atomic orbital. And what about the molecular orbital? So first of all, what is orbital? The question, what is orbital? What is orbital? Then what is atomic orbital? And molecular orbital. What is molecular? These are the questions. So what is atomic orbital? An atomic orbital are influenced by one positive nucleus. What is that? An atomic orbital are influenced by one positive nucleus, while the electrons of molecular orbitals influenced by the 2 or more nuclei depending on the number of atoms in molecule. So atomic orbital, only one atom is there. Only one. But the molecules, 2 molecules or 3 molecules. So an atomic orbital are influenced by only one positive nucleus. But whereas the electrons of molecular orbital are influenced by 2 or more nucleus depending upon the number of atoms in the molecule. What is that? Here you know that atom and molecule difference we know. So but atomic orbital definition, so what is the atomic orbital? Just one atom is influenced by the one positive, and that molecular orbitals mean 2 or more nucleus, mean 2 or more positive. So depending upon the number of atoms in a molecule. So can we write the differences and similarities? So what is the atomic orbital and molecular? Then we will discuss. So what is the difference both? Okay, we will write that one. One side is the atomic orbitals and molecular orbitals. Atomic orbitals and molecular orbitals. The first one, remember, just we write the differences. Okay? What is atomic orbital and what is molecular orbital? In atomic orbital, a region where there occurs a high probability of finding an electron in an atom is known as atomic orbital. What is that? In an atom. The region where there occurs high probability of finding an electron. In an atom, only one atom. But here, a region where there is the highest probability of finding an electron, a molecule is known as the molecular orbital. Here the probability of finding electron in a molecule, the probability of finding an electron in an atom. That is one difference you have to write. At least 5 difference we have to write. And the second one is that an electron cloud leads the formation of atomic orbitals around the atom. An electron cloud, the electron cloud in an atom, electron cloud, what happens? Leads to the formation of atomic orbitals around the atom. When fusion of atomic orbitals that have nearly the same energy takes place, then it tends to the formation of molecular orbitals. What happens? Fusion of two molecules here. Fusion of two molecules, two orbitals, two atomic orbitals. When fusion of two atomic orbitals have nearly the same energy levels, pp or ss, like same energy levels takes place, then it tends to the formation of molecular orbital. That one is the main second differences. Okay, and third difference is what? A single nucleus affect the electron cloud here. Single, because the only one atom is there, the single nucleus affect the electron cloud. In a molecular orbitals, 2 or more nuclei effect of the electron. Here 2 or more, here one electron, here one electron. So this effect is there in that. Here the single electron effect, here the single electron effect affects the electron cloud. But is the electron cloud 2 or more nuclei affect the electron cloud. Okay? And fourth one is the atomic orbitals are monocentric. What is that? Monocentric. Monocentric means what? Atomic orbitals are monocentric because they are found around single nucleus. Here that only one electron is there, monocentric. Only one center is there. That is called one center means monocentric. Because they are found by a single nucleus. Here that polycentric, because the molecular orbitals are found around the different nucleus. Hence they are the polycentric. Polycentric. Here the monocentric and polycentric. The atomic orbitals are named as here S, P, D and here. Here S, P, D, F are there in this. So what is there? Here the molecular orbitals are classified by not S, P, D, F. What? Bonding and anti-bonding. Bonding and anti-bonding. Here the classification. Here SPDF, here the bonding and anti-bonding. However, molecular orbitals can change their shapes depending upon the hybridization. Here the hybridization, they can change the shapes. They can change the shapes. Here there is no change. S orbital, spherical. P orbital, no changes. Molecular orbital can change their shapes, but here there is no possibility. So this is the differences between the atomic orbitals and molecular orbitals. But no new things are came. What are that? Bonding and anti-bonding. Bonding and anti-bonding. Okay. So bonding and anti-bonding, how it will come? How it will come? So here, so we know that already we have discussed the PP overlap, SP overlap. Oh, already we discussed in the last class. What is that? SS overlap, SP overlap and PP overlap. So these overlap already I explained it in the introduction class. Now let's look the bonding and anti-bonding present in the PP overlap. PP overlap. In the p orbital, how many orbitals are there in P? 1, 2, 3. So that is the px, py and pg. In px, in that orbital, electrons are there. Orbital. So in the p orbitals, how many number of orbitals are? 3 orbitals are there. Number of orbitals are 3. So I will explain the diagram. So please draw it carefully. First we will look the bonding and anti-bonding. So what is the difference between the bonding and anti-bonding? We have to know. So here the orbitals we know npx, npy, npz. So we will discuss 3 orbitals. Okay. In pp overlap 3 types are there: npx, npy and npz. Okay. Now first we have to look the npz orbital. Okay. So I will take the colors. Okay, first bonding orbitals. We will look the bonding. Okay. In bonding, so p orbital means you know dumbbell shape. What is the shape? So dumbbell shape. This is the shape. This is the. This is what? NPZ. What is that? NPZ. So NPZ means X direction and Z direction. X direction and Z direction. X direction and Z direction. Similarly, one more NPZ orbital. Same energy levels. You must follow the same energy levels. So same energy levels mean here that. So it is also NPZ. So now overlap. How it form in bonding? How it form? This is what? Atomic orbitals. We can say atomic orbitals. Atomic orbitals. Atomic orbitals of same energy of one atom of NPZ and another atom of NPZ. So overlapping each other atomically, then form the molecular orbital. That is what bond is formed? Sigma. So now sigma NPZ will come. So how it will come? So see. This is the sigma bond NPZ. This is the molecular orbital. Molecular orbital. So here also same direction. What direction? X and Z. X and Z direction. So this is the molecular. This is the bonding formation takes. Same energy level of NPZ and NPZ of atomic orbitals when overlapping each other to form the molecular orbital. That is the bond formation is the sigma NPZ. This is the molecular orbital. Atomic orbital, molecular. What bond is formed? Sigma bond. How it is? This is the sigma bond. X direction and Z direction. Understand this one? This is the NPZ. This is for bonding. In the case of anti-bonding, how can you know it? Same thing, so same you have to draw it. So what? Here, X direction and Z direction. X direction, Z direction. These are the anti-bonding. Atomic orbitals of NPZ, NPZ, same NPZ, NPZ, both are the NPZ. And what formation, what structure formation will come? Will come like this? No, will not come like that. Just anti-bonding. Anti-bonding means it not from the bond formation. So how it will? How it is? Just this is the formation. In sigma star, we can say sigma star. We can sigma star antibonding. This sigma is the bonding, sigma star is the antibonding. This is the gap between. Say a little gap. So here the overlap is, bonding is like this diagram, and here the separated, there is no bond between that. Okay, this is about the what? NPZ, NPZ overlapping. And can you see the NPX and NPY? So NPX and NPY. Okay, please note down, this is very, very important. You have to write the bonding atomic orbitals, and when overlap same energy levels to form the molecular orbitals like this. Antibonding, in antibonding NPZ orbitals to form the sigma star NPZ. Okay? Now NPX, we will look the NPX orbitals. NPX. So NPX. So here also we will take the NPX. In NPX, bonding and antibonding, we will look that. So NPX, antibonding and bonding, we will see this one. So bonding and antibonding, NPX and NPI, both we will look it. So what is that? Here the NP X. So X direction and Z direction. NPX. Same thing. We will draw the one more same like this only. X direction, Z direction. Okay, it is also NPX. And formation, how it form? In bonding, bond formation takes place. The bond formation is like this. Bond formation is like this. This is what? NPX. This is also what direction? X direction and Z direction. So here there in sigma, but here in NPX and NPY sidewise overlapping. So the sidewise overlapping pi complex, pi NPX formation takes place. So pi NPX bond formation. That is about the bonding. In the case of anti-bonding, so what happened? Anti-bonding. So same here, same thing. Okay. Anti-bonding here. So 4 different types here. So like this. This is the pi NPX. Pi NPX direction. See, here the bonding. This is the bonding. And this is the antibonding. In NPX. In NPZ already we have seen NPZ sigma bonding and sigma star bonding. That is the sigma star mean what? Sigma star. Sigma star is the anti-bonding. Here the pi star. Here the pi star. The pi and pi star. These terms are very important for next classes. It's a more useful. Sigma star, pi star, sigma bond, pi bond, anti-bonding and bonding. These are more important. So almost all this unit. Okay, this is the basic chapter, basic topic yesterday and today. This is anti-bonding. Similarly, this one similar. Okay, to form the pi star NPX. Okay, in the case of NPY, so please note down this one. I will draw one more. NPY. So NPY. So what is the structure like this? Here the NPY. This is same energy level. This is the NPY. NPY. This is the X direction and Z direction. Plus X direction, Z direction. So NPY. So in bonding, in bonding. So how it form in bonding? So same thing here, bonding formation is there. X direction, Z direction. So, sorry, X direction, Z direction. Okay, all NPY. Okay, next to here pi NPY, pi NPY. So that pi NPY in bonding. Here this is the bonding. So same case in anti-bonding. In anti-bonding, the same energy levels overlap, NPY plus NPY. So what compound will form? What molecular orbital formation takes place? Here this is the compound will form here. So one is here that two anti-bonding, X direction and Z direction. Here pi star NPY, pi star NPY, pi star NPY. So this is the what? Pi star anti-bonding. So this is about the bonding and anti-bonding. Okay? Orbital. What is meant by orbital? Where the probability of finding an electron is the orbital. They are the atomic orbital and molecular orbitals. So differences we know. That and then in this bonding and anti-bonding, their atomic orbitals are s orbital, p orbital, d orbital. In molecular orbital, in bonding and anti-bonding is there. The molecular orbitals are, especially in PV overlap, we have seen that NPX, NPY and NPZ. So NPZ is the formation of sigma bond and sigma star bonding and bonding and anti-bonding. Sigma star is the anti-bonding, sigma bond is the bonding. And same thing, NPX and NPY, here the formation of pi star and pi bonds. Pi NPX and pi NPY, these are the bondings. And pi star NPY and pi star NPZ, these are the anti-bondings. Okay, and finally, we know that sp overlap means that is one s orbital and one p orbital, that is the NPZ. So look it. So one s orbital, okay, round, we know that round. Okay, that is x direction and z direction. Plus and NPZ, that is NPZ, we know this is the NPZ. NPZ. This is what? Which overlap? SP overlap. SP overlap. SP overlap. SP overlap. So NP mean this is the one s orbital. Mean we can say that what? Just NS. This is the NS and NPZ. So this is also what? X direction and Z direction. So when combined to form the what compound is formed here, thus direction is this one. And formation is like this. X direction and Z direction. This is what compound is formed. Here the sigma bond, sigma NSP. What do you say? Sigma NSPZ. You can say that sigma NSPZ. So this is the formation of the molecular orbital. These are the atomic orbitals and this is the molecular orbital. This is called the bonding formation. What is that? Bonding. So where antibonding? So antibonding is will come. So in antibonding, so what will come? So in antibonding like this, and this is about the x direction and z direction. Here sigma star NSP z. Sigma star NSP. So this is about the antibonding and this is the bonding. So this is the molecular orbital and this is the atomic orbital. So two are atomical. In sp overlap, just look s orbital, p orbital means npz. So when overlapping each other to form the molecular orbitals, in the case of bonding, that is will come the sigma nspz, and antibonding, in the case of antibonding, these two are overlapping and to form the sigma star nsp. Okay, this is about the class PP overlap and SP overlap. Okay, thank you very much.